Having 3 wires to the secondary panel is unlikely to increase the probability of lightning strikes or worsen lightning damage. However, it can affect the flow of surge currents within the home. Ground rods provide a path for surge currents to flow into the earth, reducing the potential for damage to appliances and electronic devices. While having multiple ground rods can enhance grounding, the presence of just 3 rods is not likely to make a significant difference in terms of lightning protection. The primary danger of not having 4 wires to the secondary panel is the risk of electrical shock. If a fault occurs in the neutral conductor, the voltage can become unbalanced, creating a potential difference between the neutral and ground. This can create a shock hazard for anyone touching grounded appliances or metal surfaces. There are other potential issues. Firstly, the existing 3-wire connection may limit the capacity of the secondary panel, potentially leading to circuit overloads and fire hazards. Secondly, the absence of a neutral wire can result in voltage drop in the secondary panel, affecting the performance of appliances and electronics. Thirdly, using a 3-wire connection may compromise the effectiveness of circuit breakers or fuses, as the neutral current is not carried through the protection devices. It is strongly recommended that the electrical installation be corrected to include 4 wires to the secondary panel. This will ensure proper grounding, eliminate shock hazards, and improve the overall safety and reliability of the electrical system. To expand, ground rods are typically 8 feet long and made of copper-clad steel. They are driven into the earth to provide a low impedance path for fault current to return to the source. The National Electrical Code, or NEC, specifies the requirements for grounding and bonding electrical systems. Proper grounding is essential for electrical safety and for protecting equipment from damage due to voltage surges. When lightning strikes, it creates a massive surge of electrical energy. This surge can travel through the electrical system, damaging or destroying appliances and electronics. Grounding provides a path for this surge to dissipate into the earth, reducing the risk of damage. In a properly grounded system, the ground rods are connected to the electrical panel with a grounding electrode conductor. This conductor is typically made of copper and must be sized according to the NEC. The grounding electrode conductor connects to the neutral bus in the electrical panel. The neutral bus is the point where the neutral conductors from all the branch circuits are connected. The neutral conductors carry the return current from the branch circuits back to the source. In a 3-wire system, the neutral conductor also serves as the grounding conductor. This means that the neutral conductor must be able to carry both the neutral current and any fault current that may occur. In a 4-wire system, the neutral conductor and the grounding conductor are separate. This allows the grounding conductor to be sized specifically for fault current. The grounding conductor is connected to the metal enclosures of appliances and equipment. This provides a path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. Without a proper grounding system, fault current can flow through other paths, such as the human body. This can cause electrical shock or even death. In addition to grounding, bonding is also important for electrical safety. Bonding is the process of connecting all metal parts of the electrical system together. This includes the metal enclosures of appliances and equipment, metal conduit, and metal water pipes. Bonding ensures that all metal parts are at the same electrical potential. This reduces the risk of electrical shock if a person comes into contact with 2 different metal parts. The NEC specifies the requirements for bonding electrical systems. The bonding conductors must be sized according to the NEC. The bonding conductors are connected to the grounding bus in the electrical panel. The grounding bus is the point where all the grounding and bonding conductors are connected. When lightning strikes, it can also induce voltage surges in nearby electrical systems. This is known as inductive coupling. Inductive coupling can damage or destroy appliances and electronics. Surge protection devices can be used to protect against inductive coupling. Surge protection devices are installed at the electrical panel and at the point of use. They divert the surge current to ground, protecting the equipment from damage. It is important to have a qualified electrician install and maintain the electrical system. A qualified electrician can ensure that the system is properly grounded and bonded and that surge protection devices are installed correctly. Now, considering the 3-wire versus 4-wire connection, the NEC requires a 4-wire connection for a subpole or secondary panel that is fed from a main panel in a separate building or structure. The reason for this requirement is to prevent current from flowing on the grounding conductor. In a 3-wire system, the neutral conductor is also used as the grounding conductor. This means that any current that flows on the neutral conductor will also flow on the grounding conductor. This can create a shock hazard if a person comes into contact with the grounding conductor. In a 4-wire system, the neutral conductor and the grounding conductor are separate. This prevents current from flowing on the grounding conductor. The grounding conductor is connected to the metal enclosures of appliances and equipment. This provides a path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. If the customer has a 3-wire connection to the secondary panel, it is important to have a qualified electrician correct the installation. The electrician will need to run a separate grounding conductor from the main panel to the secondary panel. The grounding conductor must be sized according to the NEC. The electrician will also need to disconnect the neutral conductor from the metal enclosure of the secondary panel. The metal enclosure of the secondary panel must be bonded to the grounding conductor. As for the lightning issue, while a 3-wire system does not directly attract lightning, it can increase the risk of damage from lightning strikes. This is because the grounding system is not as effective in a 3-wire system. When lightning strikes, it creates a massive surge of electrical energy. This surge can travel through the electrical system, damaging or destroying appliances and electronics. A properly grounded system provides a path for this surge to dissipate into the earth, reducing the risk of damage. In a 3-wire system, the grounding conductor is also used as the neutral conductor. This means that any surge current that flows on the grounding conductor will also flow on the neutral conductor. This can cause the neutral conductor to overheat and potentially start a fire. In a 4-wire system, the neutral conductor and the grounding conductor are separate. This allows the grounding conductor to be sized specifically for fault current and surge current. The grounding conductor is connected to the metal enclosures of appliances and equipment. This provides a path for fault current and surge current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. It's also worth mentioning voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Voltage drop can affect the performance of appliances and electronics. In a 3-wire system, the neutral conductor is also used as the grounding conductor. This means that the neutral conductor must carry both the neutral current and any fault current that may occur. This can cause the neutral conductor to overheat and increase the voltage drop. In a 4-wire system, the neutral conductor and the grounding conductor are separate. This allows the neutral conductor to be sized specifically for the neutral current. This reduces the voltage drop and improves the performance of appliances and electronics. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. The maximum voltage drop for branch circuits is 3%. The maximum voltage drop for feeders is 5%. It is important to size the conductors properly to minimize voltage drop. Larger conductors have less resistance and will result in less voltage drop. Now let's consider circuit protection. Circuit breakers and fuses are used to protect electrical circuits from overcurrents. Overcurrents can be caused by short circuits or overloads. A short circuit is a low resistance connection between two conductors. An overload is when a circuit is carrying more current than it is designed to carry. Circuit breakers and fuses will trip or blow when an overcurrent occurs. This will de-energize the circuit and prevent damage to the wiring and appliances. In a 3-wire system, the neutral conductor is also used as the grounding conductor. This means that the neutral conductor must carry both the neutral current and any fault current that may occur. This can make it difficult for circuit breakers and fuses to detect overcurrents. In a 4-wire system, the neutral conductor and the grounding conductor are separate. This allows the circuit breakers and fuses to detect overcurrents more easily. This provides better protection for the wiring and appliances. The NEC specifies the requirements for circuit breakers and fuses. The circuit breakers and fuses must be sized according to the ampacity of the conductors. The ampacity of a conductor is the amount of current that the conductor can carry safely. So, in summary, correcting the 3-wire connection to a 4-wire connection is essential for electrical safety. It will reduce the risk of electrical shock, improve the performance of appliances and electronics, and provide better protection for the wiring and appliances. It is important to have a qualified electrician perform the work to ensure that it is done correctly. The electrician will also be able to assess the overall grounding system and make any necessary repairs or upgrades. To reiterate the importance of grounding, a properly installed grounding system helps to minimize the risk of damage from lightning strikes. While it cannot prevent lightning from striking, it provides a safe path for the electrical energy to flow into the earth, reducing the risk of damage to appliances and electronics. Surge protection devices can also be installed to provide additional protection against lightning strikes. These devices divert the surge current to ground, protecting the equipment from damage. Regular inspections and maintenance of the electrical system are also important. This will help to identify any potential problems and ensure that the system is functioning properly. If you notice any signs of electrical problems, such as flickering lights or buzzing sounds, contact a qualified electrician immediately. Don't attempt to repair electrical problems yourself, as this can be dangerous. Having a qualified electrician inspect the electrical system regularly will help to ensure the safety of your home and family. And it's crucial to address the 3-wire situation as soon as possible to mitigate potential hazards. The electrician should also evaluate the existing ground rod system to ensure it meets current code requirements. The NEC provides specific guidelines on the number, spacing, and installation of ground rods. While 3 ground rods are present, their effectiveness depends on factors such as soil conductivity and the distance between them. The electrician can perform tests to determine the grounding impedance and ensure it is within acceptable limits. If the grounding impedance is too high, additional ground rods may be needed to improve the grounding system. The type of wire used for the grounding electrode conductor is also important. Copper wire is the preferred material for grounding electrode conductors due to its high conductivity and corrosion resistance. Aluminum wire can also be used, but it must be properly sized and installed to prevent corrosion. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. It is important to use the correct size grounding electrode conductor to ensure that it can carry the fault current safely. The connection of the grounding electrode conductor to the ground rods is also critical. The connection must be made with approved connectors that are designed for direct burial. The connectors must be properly tightened to ensure a good electrical connection. The ground rod should be driven into the earth at least 8 feet deep. The top of the ground rod should be below the frost line to prevent heaving due to freezing and thawing. The ground rods should be spaced at least 6 feet apart to provide adequate grounding. In addition to ground rods, other types of grounding electrodes can be used. These include metal underground water pipes, metal building frames, and concrete encased electrodes, also known as UFA-grams. The NEC specifies the requirements for each type of grounding electrode. If a metal underground water pipe is used as a grounding electrode, it must be electrically continuous and in direct contact with the earth for at least 10 feet. The water pipe must also be bonded to the electrical system with a bonding jumper. If a metal building frame is used as a grounding electrode, it must be effectively grounded and bonded to the electrical system. The building frame must be electrically continuous and in direct contact with the earth. If a concrete encased electrode is used as a grounding electrode, it must consist of at least 20 feet of bare copper conductor encased in concrete. The concrete must be in direct contact with the earth. The concrete encased electrode is typically installed in the footing of a building. Proper grounding and bonding are essential for electrical safety and for protecting equipment from damage. It is important to have a qualified electrician install and maintain the electrical system to ensure that it is properly grounded and bonded. Remember to consult the latest edition of the NEC for the most up-to-date requirements for grounding and bonding electrical systems. Furthermore, consider the potential impact on insurance coverage. An improper electrical installation, such as a 3-wire connection to a secondary panel where a 4-wire connection is required by code, could potentially avoid or limit insurance coverage in the event of fire or other electrical incident. Insurance companies may require that electrical systems be installed and maintained in accordance with the NEC and local codes. If an inspection reveals that the electrical system is not in compliance with these codes, the insurance company may require that the system be brought up to code before providing coverage. It is always a good idea to check with the insurance company to ensure that the electrical system meets their requirements. Documenting the electrical work that has been performed is also important. This includes keeping records of all electrical inspections, repairs, and upgrades. The documentation should include the date of the work, the name of the electrician who performed the work, and a description of the work that was performed. This documentation can be helpful in the event of an insurance claim or if you sell the property. Obtain copies of permits that were issued for any electrical work that was performed. Permits are required for most electrical work to ensure that it is done safely and in accordance with the electrical code. The permit will be inspected by a qualified electrical inspector to ensure that the work meets code requirements. This provides an extra layer of protection and ensures that the electrical system is safe. Ignoring electrical code requirements can have serious consequences. In addition to the risk of electrical shock and fire, it can also result in fines and penalties. The electrical inspectors have the authority to issue fines for code violations. They can also require that the electrical system be brought up to code before it can be used. In some cases, they may even shut down the electrical system until the code violations are corrected. Therefore, it is always best to follow electrical code requirements and have a qualified electrician perform any electrical work. This will help to ensure the safety of your home and family and avoid any potential problems with the electrical system. In addition to the issues discussed earlier, a 3-wire connection to a secondary panel can also create problems with electronic equipment. Many electronic devices are sensitive to voltage fluctuations and electrical noise. A 3-wire connection can increase the amount of electrical noise in the system, which can cause electronic devices to malfunction or fail. A 4-wire connection provides a cleaner and more stable power supply, which can help to improve the performance and reliability of electronic equipment. This is especially important for sensitive electronic equipment such as computers, televisions, and audio equipment. It is also important to consider the future needs of the electrical system. As technology advances, we are using more and more electronic devices. This increases the demand for electricity and puts more strain on the electrical system. A 3-wire connection may not be able to handle the increased demand for electricity. A 4-wire connection provides more capacity and can handle the increased demand for electricity more easily. This will help to ensure that the electrical system can meet the needs of the home for many years to come. When correcting the 3-wire connection to a 4-wire connection, it is important to use the correct type of wire. The NEC specifies the type of wire that must be used for different applications. For example, non-metallic sheath cable or NM cable is commonly used for wiring branch circuits in homes. NM cable contains 2 or more insulated conductors and a belt grounding conductor. The conductors are enclosed in a plastic sheath. NM cable is relatively inexpensive and easy to install. However, it is not suitable for use in wet or damp locations. For wet or damp locations, such as bathrooms and kitchens, it is necessary to use a different type of wire, such as THHN or THWN wire. THHN and THWN wire are single conductor wires that are insulated with the thermoplastic material. They are more resistant to moisture than NM cable. THHN and THWN wire must be installed in conduit to provide protection from physical damage. Conduit is a metal or plastic pipe that is used to enclose and protect electrical wiring. There are many different types of conduit, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The type of conduit that is used depends on the application and the location. Rigid metal conduit, or RMC, is the strongest type of conduit. It is typically used for underground installations and for installations where the wiring is subject to physical damage. Intermediate metal conduit, or IMC, is a lighter weight version of RMC. It is used for similar applications as RMC, but it is less expensive. Electrical metallic tubing, or EMT, is a thin-walled conduit that is commonly used for indoor wiring. EMT is easy to bend and cut, making it a popular choice for residential wiring. Flexible metal conduit, or FMC, is a flexible conduit that is used for connecting equipment to the electrical system. FMC is easy to bend and can be used in tight spaces. The type of wire and conduit that are used must be suitable for the application and the location. It is important to consult the NEC for the specific requirements for wiring different types of circuits. In addition to the type of wire and conduit, the size of the wire is also important. The size of the wire is determined by the ampacity of the circuit. The ampacity of a circuit is the amount of current that a circuit is designed to carry. The NEC provides tables that specify the minimum size of the wire based on the ampacity of the circuit. It is important to use the correct size wire to ensure that the circuit can carry the load safely. Using undersized wire can cause the wire to overheat and potentially start a fire. It's best to consult with a qualified electrician to determine the correct type and size of wire for your specific application. The electrician will take into account the load on the circuit, the distance the wire will run, and the environmental conditions. They will also ensure that the wiring is installed in accordance with the NEC and local codes.